All changes to the climate system on the Earth affects the amount of energy that either enters or leaves the system and changes the equilibrium, forcing the temperature to rise or fall. These influences are known as climate forcing. The natural climate forcing have the changes in areas like the brightness of the sun. Evidences of presence of melanchoic cycles are visible on the Earth. These are small variations on the orbit of the Earth and have an axis of rotation that occurs over a period of thousands of years. We have other kinds of particle pollutions like aerosols, which are all man-made. These are called man-made forcing, which absorb the sunlight that comes in. Other factors like deforestation change the manner in which the surface of the Earth reflects and absorbs sunlight. There is a constant rising concentration of carbon dioxide in the atmosphere, which reduces the heat that is radiated to space. Thus, a forcing can result in feedbacks and either intensify or weaken the initial forcing. A good example of a feedback is the loss of ice at poles, which makes the entire radiation less effective. The Earth's heat budget. What is Earth's energy budget? The carbon dioxide in the air forces the energy budget of the planet Earth to go out of balance, and this it does by absorbing the infrared energy or the heat radiated by the surface of the Earth. The thermal infrared energy is absorbed with an extremely high wavelength. In fact, this is incomparable with other gases like water vapor, which are also part of a higher energy spectrum. Water vapor is a very powerful absorber and is a transparent medium of wavelength, which allows the relative cooling of the Earth's radiated energy surface. Since water vapor is transparent, it is like a window to the atmospheric energy, and this window is very crucial to wavelengths of 10 micrometers. When the wavelength is around 8 and 14 micrometers, then the transparency is partial and not total. So, in short, the outgoing thermal infrared energy is absorbed by the most abundant greenhouse gas, which is water vapor. So, this means that the Earth absorbs around 70% of the solar energy, but does not let out an equivalent amount of heat. This creates an imbalance, and this is what the Earth's heat budget is all about. Climate change and energy budget. The surface temperature of Earth does not create an imbalance and change instantly due to the concentration of greenhouse gas. It takes an eternity for the impact of such a change to be felt. This creates a lag, and this is seen in the manner in which the global ocean gets heated up. Climate thus gets a thermal push, which warms the surface and results in a slow but steady change of climatic conditions. The greenhouse gases are known to create an imbalance of energy, and this is going to continue for some time. There will be a sudden increase in the radiated heat when the temperature of the Earth's surface increases. The climate change would stabilize when the concentration of the greenhouse gases stabilizes. Until then, the absorbed solar energy would be greater than the thermal infrared energy that is released. Causes for changes in the Earth's balance. There are many things that change the balance between the outgoing and the incoming energy in the entire climatic system. These are called forcing. There are, as mentioned above, two kinds of forcing, natural and man-made. Volcanoes form natural forcing, while air pollution and greenhouse gases form man-made forcing. Earth has a powerful climatic system. The land, atmosphere, and the oceans absorb all the solar power and warm the entire Earth system. It is said that around 240 watts of solar power per square meter is absorbed. 1 watt is 1 joule of energy per second. This results in melting ice and snow, accelerating the rate of evaporation and increasing the process of photosynthesis. This results in a change in the Earth's balance. Sun, Earth, Universe and heat budget. The Sun does not actually heat the planet evenly. The Earth is spherical and the Sun is able to heat only the regions around the equator. The polar areas are not warmed by the Sun. The ocean and the atmosphere are always at work trying to reduce the solar heat and the imbalances it creates through the process of evaporation and rainfall, convection and ocean circulation. The combination of the ocean circulation and the atmosphere is called the heat engine of the Earth. The heat engine of the Earth helps to distribute the heat evenly from the equator to the poles. If this does not happen, then the Earth would be very hot. The temperature does not rise to a great level because the atmosphere and the surface are always in the process of radiating heat to space. This is what the Earth's energy budget is all about. The net flow of energy into and out of the system of the Earth is called the Earth's energy budget. Energy concept and the Earth. Any matter in the universe radiates energy across a set of wavelengths if it has a temperature that is above absolute zero. It is well known that any hot object has a short wavelength. These hot objects are said to release X-rays and gamma rays. The cooler objects are said to emit more wavelengths and the radiation is longer. It is inclusive of thermal infrared and visible light along with microwaves and radio frequencies. The temperature of the surface of the Sun is 5500 degrees Celsius and one can see in the peak radiation in visible wavelengths usually found in light. When viewed from space, Earth seems to have a temperature of around -20 degrees Celsius. It radiates a kind of energy that ends in the thermal infrared wavelengths. Sun and the heat conditions on Earth. The Sun delivers around 1360 watts per square meter. The surface has a temperature of around 5800 Kelvin and most of this energy is visible to the naked eye. The average distance of the Earth from the Sun is around 150 million kilometers and that average intensity of the solar energy that reaches the uppermost atmosphere is around 1360 watts per square meter. These measurements were made by the satellite missions from NASA. This is called total solar irradiance. This is also called the solar constant. This solar irradiance is the highest power that it can give and this is delivered to an area that is perpendicular to the incoming light. If one is calculating with the help of geometry, then this actually limits the actual solar energy being intercepted by Earth. Thus, only half the Earth is always lit by the Sun and not the other one. This in turn reduces the solar irradiance. Thus, the energy from sunlight is not spread in an even manner on the planet Earth. There is one hemisphere which is always not in the area of solar radiation. Full intensity solar radiation is felt on the side with light only in places where there is direct sunlight falling. Facts about the solar radiation. There are some facts and interesting observations of the solar radiation. Solar radiation, the maximum power. Solar radiance is the maximum power delivered by the Sun on Earth. The Earth is spherical and thus gets the full impact of the solar radiation only in areas where sunlight directly falls. At other angles, the light is at an angle. The decrease in the angle of illumination as the latitude increases brings down the radiance of the Sun. Thus, latitude and time is dependent on the amount of solar radiation received at the surface of the Earth. The angle of incoming sunlight affects the time of the day. The amount of sunlight on the top of the surface of planet Earth is around 1/4 of the total radiance and is around 340 watts per square meter. When the incoming flow of radiation from the Sun and the outgoing flow of heat to space are in balance, then the Earth is said to be in radioactive equilibrium. Imbalance in heating. Around 340 watts per square meter of radiance is an average accepted globally. Solar illumination is dependent on time, space and position of latitudes. We assume that the imaginary axis on planet Earth is slanting, thus leading to an imbalance in heating, with the areas near the equator getting more heat than the ones on other sides. If the axis had been an imaginary vertical one, then there would have been no heating imbalance. Thus, indirectly, the energy received by Earth each day is dependent on latitude. The highest inputs are during high latitudes in the summer season when there are long days. Some latitudes at the poles get no light at all in winter. The southern hemisphere gets more energy in the month of December than the energy that the northern hemisphere gets in June. Thus, even if there is lot of illumination at the poles in the summer season, the incoming light is represented by sea ice and bright white snow, thus bringing down the potential of solar heating. Earth heat budget and net heating. Thus, it is seen that there are a lot of differences in the illumination of the solar energy and the net heating. At any point on the planet, net heating would be the difference between the amount of sunlight received and the amount of heat radiated by the Earth. Thus, there is a surplus of energy in the tropics as the amount of sun received is more than the amount radiated. Similarly, there is a deficit of annual energy because the amount of heat radiated in space is more than the amount of absorbed sunlight. In these conditions, areas near the equator get around 200 watts and those near the poles had more green and blue radiations than they absorbed. There was a little balance in mid-latitudes. Thus, there is a kind of heat engine that is formed due to this heating imbalance between the poles and the equator. This is under the concept that the climate is an engine utilizing heat energy and keeps the oceans and the atmosphere in motion. Convection, evaporation, winds, rainfall, and ocean currents are part of the heat engine of the Earth. Solar energy and heat balance. Finding out the necessary values for the flow of energy in the Earth is a way of understanding its relation with the climate change. All are estimates and they all have a kind of uncertainty. Estimates usually come from ground-based observations, satellite observations, and many numerical weather models. Earth's heat engine helps in transferring heat from one place to another. It also enables the heat to move from Earth's surface. The processor flow of outgoing and incoming energy is what makes up the energy budget for the Earth. Around 29% of the solar energy striking the surface of the Earth is sent back to space with the help of atmosphere, clouds, or snow and ice. However, energy does not play a major in the climate of planet Earth. Around 23% of the solar energy is taken in by the atmosphere. When this energy is absorbed, the molecules and the atoms making up the material get excited and they start moving in random motion. The temperature of the Earth would thus be like the wash basin with a leaking faucet and a blocked drain pipe. When there is a continuous leakage in the same, Temperature does not increase, but molecules and atoms on Earth are also at the same time radiating energy of the thermal kind. This amount of heat that is radiated by a surface with the proportion being proportional to the fourth power of the temperature of the Earth shows that there is an effort by nature to create a heat balance. Radioactive cooling and heating of Earth. When heat loss occurs at a large extent with a very small increase in temperature, then it is called radioactive cooling. This is the main way of preventing unwanted heating on Earth. It is known by now that the amount of solar energy falling on the Earth is around 340 watts. Out of this, around 29% is thrown back to space, mainly by the clouds and other bright surfaces. Out of the incoming energy, around 23% is absorbed by the particles in the air, dust, and gases in the surroundings. Thus, around 48% is absorbed on the surface of the Earth. This absorbed sunlight is again balanced with the help of the heat that is radiated from the surface of the Earth and the atmosphere. Thus, most of the heat that escapes is in and around the equator, and the clouds around here did not allow the heat to escape. The polar regions also in turn do not radiate much heat. If there has to be stability, then the surface of the Earth and the atmosphere should absorb around 71% of the incoming solar radiation. In this way, there is more space for the average temperature in the planet to be stable and firm. Surface energy budget. The climate system of Earth manages to balance the energy budget. We have to look into all the processes that occur at the three levels. This includes the surface of the Earth, where you would get the most of solar heating, the atmosphere, and the edge of the Earth, where you can see that the sunlight enters the system. The amount of outgoing and incoming energy has to be equal. We also know that around 29% of the sunlight coming in is thrown back to the universe by the particles in the surroundings. Therefore, around 71% is absorbed by the atmosphere. If there has to be an energy budget for Earth, then solar energy has to be taken care of well and has to be thrown out. Energy leaves the surface of the Earth through convection, evaporation, and thermal radiation. Evaporation. Around 25% of the solar energy that is coming is lost through evaporation. When molecules of liquid water absorb the solar energy that is hitting the surface of the Earth, then they undergo a change from the liquid to gas. The heat energy is the reason for this, and the random motions of the molecules of water vapor kills is the reason for this. When the molecules condense, they fall as rain. The heat that is released in the atmosphere is the main step towards change in the climatic condition. This is the reason you would see showers of cumulus clouds taking energy away from the surface of Earth. Solar heating, thus, is directly responsible for evaporation. The moist air creates buoyancy and moves energy from the surface of the earth to higher layers of the atmosphere. Then you have an addition of 5% transfer of incoming solar energy from the surface to the atmosphere, thus making the ground very buoyant and warm. Thus, we can see that the atmosphere is warmer when we reach the surface, but gets cold when we are at a height. You are now left with around 17% solar energy, which leaves the surface in the form of thermal infrared energy. This is also heat and is mainly dominated by molecules and atoms. This upward push results in the heat to flow from the air towards the ground. All these are also related to the climate change. The energy budget in atmosphere. It now becomes imperative that we find the right values for the manner in which the energy has to flow in the planet. So, it is important to understand its relation with the climatic changed conditions. There is a lot of heat on Earth. The heating capacity of the Earth helps in transferring heat from one place to another. Flow of energy in the atmosphere has to be monitored and balanced by a certain flow of energy. Atmosphere is said to radiate thermal infrared energy, which is equal to 59% of the total solar energy. If it is radiating so much, it should also be absorbing that much. Where does this energy occur? Water vapor, clouds, aerosols have been directly part of the incoming solar energy. If the total flow of energy is equal to the thermal infrared radiation, then the remaining fraction of airflow should be coming from energy. Greenhouse gases and Earth's heat budget. The major gases in the atmosphere are nitrogen and oxygen, and they allow sunlight to pass through. They can also allow threaded in case they are transparent. But carbon dioxide, water vapor, methane, and some gases are not dependent on the transparency of the substance. The total percentage radiated by the sun is 17%. There is around 12% radiated. The difference in the two is around 5 to 6%, and this is what is sent back to the atmosphere along with the greenhouse gases. This is what is called the heat budget of the Earth. Conclusion. Thus, it is seen that the simple process of the radiation of the sun rays and the related thermal infrared ray absorption causes an imbalance on the surface of the Earth. However, through the natural process of balancing the percentage of radiation and absorption, there is a continuous balance between the heat rays on the Earth and three related climate change. With the greenhouse gases absorbing the thermal infrared ray energy, there is a significant rise in temperature and they throw this energy all around. Thus, this continuous process of maintaining a balance on the surface and creating proper conducive environment for the surroundings is what Earth's heat budget is all about. This is also combined with the process of global climatic change, thus creating a continuous process.